We're going to be finishing off our trigonometry review by looking at case 2 and case 3. So, case 2 is finding an unknown side when the unknown is a denominator. Okay. So what I'm going to do is I'm going to draw out 3 triangles. I'm going to have a go at the first one, and the other 2 are for you to practice. So you pause the video, press play, see how we go. There's a bit of a recap. We've got SO, CA, TOA, which all makes the equations, sine theta, cosine theta, tan theta. Now, here we go. Let's have a look at these 3 triangles. Okay, there we go. There's our 3 triangles. We're gonna tackle the first question there on the left, and then once you've got the alterns. So, which is the same thing here. Our first step is we've got a label. Second step, we use rule. Third step, solve. And fourth step, units and 2 decimal places. So we just do the same thing. So let's label the triangle here. You've got hypotenuse. And then this one here, we've got our adjacent. So remember, it's always from the perspective of the angle theta. So 56 degrees, it's adjacent or next to. Now, we don't care about the opposite in this case. There's nothing there, so we're going to leave it. What trig function uses a and h? We've got ca. So ca, write out the equation, and then sub in. Now, theta is 56 degrees. The angle, A is 18 and H is X. Now here we're going to just pause for a second and have a look at the difference between this example and the previous example. Where's our X? The X is on the denominator. Now, if we go up to the previous example, do you see that our X is on the numerator? Okay. Now, rule of thumb, if the x is on the numerator, we just times by 12 in this case, and just do what we normally do with algebra. When the x is on the denominator, there's a little trick that we do. It's called swapping. Okay. So what we do is we have a look at that cosine 56 block, and we're going to move it to where we see the x currently. Then we're going to get this x block, and we're going to move it to where that cosine 56 was. So essentially, we are swapping. Now, there's an algebraic reason for this, okay? You can go into that if you want, but really, this is our shortcut, okay? So what we're going to do now is we're going to swap. Now, we're at a point where we can plug this into our calculator as we have x by itself. So here we go. I've got 18, and then I'm going to use a fraction here. Oh, in fact, let's just clear all. Fraction first, 18, then on the bottom, I'm going to go cosine 56, and remember to close that bracket, otherwise it breaks. Okay, so we've got 32.19, then we add our units, meters. So there's our answer, 32.19 meters. What I'd like you to do is have a go at your turns to the right, so pause the video, do them, and then press play and see how you went. We're going to go through the answers now. First step, you should have this is hypotenuse, this is opposite. Next, we're going to choose SO TOA. Next, sine theta is equal to opposite and hypotenuse. Next, we sub in theta is 60 degrees, 15 on x. Next, we're going to swap those two. So you've got x is equal to 15 on sine 60 degrees, and then we plug in. So let's type that in, 15 And then down here, we've got sine 60. Yet again, remember to close the brackets, otherwise it won't work. So there we go. 17.32, what's our units? Millimeters. Do you notice each time I'm going to 2 decimal places and I put my units in every single time? Okay, let's have a go at this last one. So what you should have is a hypotenuse here and an adjacent here. Okay, so this one again is cosine, because it's ca. Adjacent on hypotenuse, sub in 39 degrees, 19 over x, swap, and then plug in. So we get 31.57 at the units. This one is centimeters. See there? It says centimeters. Okay? Sort of hard to read that one. So there we go. We've looked at case 2. Now we're going to move on and look at case 3. This is finding unknown angles. So, case 3. So, in this case, we want to find unknown angles. Now let's just look at one scenario. If I've got this cosine theta is equal to 0.5, I want to find what the unknown angle is. So we can see here that this is the unknown angle. Now the problem here is that, do you see how theta isn't by itself? It has this pesky cosine here. There's a way around this. We can actually get rid of a cosine by introducing something which is the inverse of a cosine. Okay, now it's an algebraic technique and it's a way of getting rid of them. So what that's called is inverse cosine. Now, when inverse cosine hits cosine, they disappear, right? They cancel each other out. But with algebra, what I do to one side, I've got to do to the other. So what inverse cosine does is it helps us get our values by themselves. So now theta is by itself, and we can plug this into our class pad. Okay, so if I go function and then inverse cosine and then go back to 0.5, we can see that the angle was 60 degrees. Okay, it's absolutely amazing how this works, and we can practice a few more. We've got sine theta is equal to, let's say, 0.5 again. Go inverse sine 0.5, and let's say we've got another one. We've got tan theta is equal to 45 degrees. Okay, so use inverse tangent. Oh, sorry, I meant to say, let's say 1. That was really embarrassing. And then inverse tangent of 1. Okay, now let's just practice putting these in. Now, in your calculator, you have to press shift, then sine to get inverse sine, shift, then cosine to get inverse cosine, and shift, and then tangent to get inverse tangent. So I'm just going to practice putting these ones in now, but obviously my calculator is different from yours. So sine, and then we put in 0.5, we get 30 degrees. And then let's go inverse tangent of 1. So function tangent of 1, we get 45 degrees. Okay, now these are special angles that I've chosen. As you can see, they've come out nice and whole. Very rare that it comes out nice and whole. So what we're going to do is we're going to go through 3 triangles and practice this technique. Okay, so I'll just label here, this is called an inverse function. So inverse cosine, inverse sine, inverse tan. So let's draw these out now. As always, I'm going to go through 3. Okay. So there we go. Let's have a go at the one on the left, and then you're going to have a go at those two on the right. So first thing, what we do is we label. Okay. So we've got hypotenuse we don't care about. Here's our angle. So this must be our adjacent side, and this is opposite the theta. So this is going to be our opposite side. Now, what uses, so I'm just going to write this up. SOHCAHTOA TOA. Which one uses O and A? We can see it's tan, TOA. So let's write it out. TOA. So we're going to write out our equation. Tan theta is equal to O on A. Now let's sub in what we know. The theta stays as theta, then opposite goes to 20 and adjacent goes to 26. Now, what was our trick for getting rid of that tangent? We take the inverse tangent. So here we go. Like that. Now we can write out what our answer is. So we go functions, tangent, and then we go 20 on 26. We can see the answer is 37.57 degrees. Cool. Now, what I want you to do is pause the video, have a go at the questions to your right. You may note that there's a different symbol here. This stands for alpha. It's just another way of saying theta, so it's exactly the same thing. Okay, so we're going to go through these examples now. Let's see how you went. So this one here was our hypotenuse, as is opposite this, and we've got this as our adjacent because it's next to the angle. Next step is we have to choose our function, so ka, write out our equation, sub in, rearrange by taking inverse cosine, and then solve. Now I've got the answer here as being function cosine 47.01 degrees. Okay, now the very next one, we're going to have the same thing. We're going to have a go at that one. So we've got H, hypotenuse again, and here's our alpha. Opposite alpha is O. So we're going to use SO here. Sine theta is equal to opposite on hypotenuse. Sub in. Take the inverse. And then solve. Okay, there's our answer. We've got alpha is equal to 53.13 degrees. There we go, there we have it. We can now solve and find angles using for case 3 using this process. Now, one final note, what happens if your calculator says undefined? Well, this typically happens for sine and cosine. What happens there is if you put in, say for instance, this is 10 and this is 5, you will definitely get a broken answer. It's not possible. Same for this one here. The reason for this is you've probably swapped the top with the bottom. Okay, so just make sure that your numerator is always smaller than your denominator for sine and cosine. You probably have swapped them around and got it the wrong way around, and that's why a calculator is saying undefined. Well, thanks very much for your time. I hope you found these videos useful.